Hello everyone. This is the problem on pile foundation, and it was asked in GATE 2017. Let us look at the problem. Two identical concrete piles having plan dimension 50 centimeter by 50 centimeter. That means it is a square in cross section, are driven into a homogeneous sandy layer. Consider the bearing capacity factor NQ 24 for phi equal to 30 degree. If QP1 and QP2 represent the ultimate point bearing resistance of the pile under dry and submerged conditions respectively, which of the following statements is correct? A. QP1 is greater than QP2 by about 100%. That means we will have to find out the point bearing resistance QP1 and QP2 for both the piles, and piles are identical. So let us draw the piles. One of the pile this is in dry sand, and another part it is identical. So but this is embedded in saturated sand. So it's given submerged or submerged sand. So that means the water table is here, isn't it? And this is dry. The unit weight of dry sand, gamma, is given to you as 18 kilonewton per meter cube, and here the saturated unit weight is given as 19 kilonewton per meter cube. Phi is 30 degree, the value of NQ is known, and we need to find out, this is one in dry sand and this is in submerged sand. This is number 2. So here the point bearing resistance QP of 1 and point bearing resistance QP of 2. And phi here is 30 degree, phi here also it is 30 degree. So with these informations, how will you find out the point bearing resistance? The point bearing resistance QP can be found out from basic formula, that is 3 times Q NQ or Q bar NQ multiplied by area of the pile at its end. So this is the formula. So therefore we can find out QP1 and QP2. So QP1, here there is the surcharge, effective surcharge, you can calculate it at pile's tip or pile's end. So at this point, the effective surcharge that you can find it out. So calculate this one. So 3 times Q bar will be gamma D, that is 18, multiplied by the length of the pile is given here 20 meter. So this is L equal to 20 meter. Here also L equal to 20 meter. So length of the pile is known to us. Therefore, the surcharge here is going to be 18 into 20, right, into NQ. NQ is already given for 530. The value of NQ is 24. So this will be into 24. So this is the unit point bearing resistance, and this needs to be multiplied with the area. So what is the area? Area is going to be AE, because the diameter is going to be same, it will be AE over here. So this is QP1. Now how to find out this value QP2? QP2 can be found out again. So let's calculate the value of QP2. So the value of here for submerged condition, the point bearing resistance will be 3 times Q bar. Here you should calculate, that is going to be gamma prime. Gamma prime will be 19 gamma saturated minus gamma W, that is 9.81, into length of the pile, that is 20 meter, multiplied by NQ. So this is going to be 24. This is the QP2 multiplied by area of the pile at its end. So when you want to find out whether QP1 is greater than or less than QP2, let's find out the ratio of QP1 upon QP2. So if you calculate it, therefore, if you calculate QP1 upon QP2, 3 into 18 into 20 into 24 into 8 divided by 3 into the difference of the two, 19 minus 9.81, multiplied by 20 into 24 into 8. Calculate this. This expression is given by basic. And popularly used in pile foundation. So you can just 3 gets cancelled, 20 goes out, 24 goes out, A goes out. So finally what remains is to be calculated, 18 divided by 19 minus 9.81. So if you calculate it, 18. You get 1.958. So therefore, QP1 is greater than or equal to is greater than QP2 by greater than QP2 by 95.8%, almost equal to 100%. So here, if you see the options, the correct statement will be QP1 is greater than QP2 by about 100%. So here, in a simple manner, you can just calculate it and find out that the QP1 is greater than QP2 by almost 100%. So this is the answer. Thank you. This is what we wanted to do in this problem.